So let's talk about something that's literally everywhere, powering pretty much every app on your phone, the Application Programming Interface, or as you know it, the API. We're going to break down what separates a good API from a truly great one.
Have you ever ordered food on an app and just kind of wondered, how does it all work? How does your phone magically know the restaurant's entire menu, send your order perfectly, and then track it all the way to your door? Well, that magic has a name, and it's API. It's the invisible conversation happening behind the scenes that lets all these different apps and services talk to each other.
So what is an API really? The simplest way to put it is this. It's a documented, official way for some other program to interact with your code. And the key part here is that it only defines how to interact. It doesn't tell you anything about how the code works on the inside. You don't need the restaurant's secret recipe, you just need the menu to place your order. That menu? That's the API.
Honestly, the best way to think about an API is as a contract, a really clear one. It lays out the rules of the game. It says, if you ask me for this and you give me this specific information, I promise to give you this exact thing back in return. It's a guarantee of what the code will do without getting into all the messy details of how it does it.
Okay, so let's see what this contract actually looks like in the real world.
Let's imagine we're building a feature for WhatsApp, and what we need to do is get a list of all the administrators for a specific group. The API to do that would have a very specific contract. Let's break down what that would look like.
See, the contract is super clear. The function name tells you what it does, get admins. Simple enough. The parameters tell you what it needs from you, in this case, just a group ID. If you give it that, the successful response is a list of admin objects. And just as important, it tells you what might go wrong, the possible errors, like the group not existing. Everything you need to know is right there.
All right, so how do we go about designing a good API from scratch? Well, it really just boils down to asking three simple key questions. First up, where does this thing belong? This is all about organization. I mean, you wouldn't put your socks in the kitchen cabinet, right? It just wouldn't make sense. The same exact principle applies to your code.
So if your system is built with microservices, all these little individual services that each handle one specific job, then an API for getting group admins has a very obvious home. It belongs in the group service. This keeps everything clean, predictable, and way easier for other developers to find and use.
Okay, the second question, and this one is a biggie, maybe the most important one. What does it actually do? And the answer to that should be screamingly obvious just from the API's name.
Your API's name has to be honest. It's that simple. If a function is called getAdmins, it better do one thing and one thing only, get admins. If it secretly returns other group information too, then the name is a lie. It's misleading. A more honest name would be something like get admins and groups. You have to be clear and precise.
And finally, question 3, what does this API need to do its job? We're talking about its parameters, the bits of information you have to give it so it can give you something back.
The golden rule here is to be a minimalist. Only ask for what is absolutely 100% necessary. Don't add extra parameters just in case you might need them later. The one big exception here is for performance. If your service is getting hammered with traffic, you might add an extra parameter to save a slow network call. But that's a trade-off, and if you do it, you have to go back and ask yourself, is the API's name still honest?
And there you have it. Where does it belong, what does it do, and what does it need? That's the core blueprint. Get those 3 things right, and you're on your way to a clean, understandable API.
But, right now, this is all just a concept, right? A contract on paper. How do we actually make this thing real and bring it to life on the internet? Let's translate this blueprint to the web.
This is where we take our abstract idea of a function and turn it into a concrete HTTP request. The actual language that the web speaks.
And what's really cool is how our 3 questions map perfectly to an HTTP request. Where it belongs? That's your URL. What it does? That's your method, like get to retrieve data. And what it needs? Well, that's the payload, which is just the data you send along with your request. It all lines up.
Now this slide shows a super common mistake. On the left, you've got a clean API. The URL and the method clearly define the action. It's beautiful. But on the right, that's the dirty version. It uses a generic URL and stuffs the real action, get admins, inside the payload. It might work, but it's messy, it's confusing, and trust me, when your system gets bigger, this becomes an absolute nightmare to maintain.
Okay, we've got the fundamentals down. So let's level up and talk about some of the more advanced,
trickier challenges you'll run into when designing APIs.
A really key principle is to avoid unexpected side effects. So imagine an API called setAdmins. You'd expect it to do just that, right? But what if the user you're trying to make an admin isn't a member of the group yet? Should the API just add them for you? And what if the group doesn't even exist? Should it create it? Those are side effects, actions that happen beyond what the name promised. And in general, you want to avoid them.
Now, sometimes you do want multiple things to happen all at once or not at all. That's called atomicity. For instance, maybe you want to create a group and set its admins in one single atomic step. You can totally build an API for that, but, and this is a big but, you can't just call it setAdmins. The name has to stay honest. You'd call it something like create group and setAdmins. Atomicity is powerful, but it's never an excuse for a poor, misleading name.
Here's a problem you are guaranteed to hit eventually. What do you do when your API needs to return a massive amount of data? Imagine fetching all 200 members of a huge group, and each person's profile is full of details. Sending that all in one giant data dump is going to be slow and inefficient for everyone.
You've basically got two main strategies here. The first is pagination. This puts the responsibility on the client, the app asking for the data. The client asks for data in chunks or pages. It says, okay, give me the first 10. Then, now give me the next 10. This is perfect for things like an infinite scrolling feed. The other strategy is fragmentation. Here, the server does all the work. It knows the response is huge, so it breaks it up into smaller pieces and sends them one by one. The choice really comes down to this. Who do you want to be in control?
And that brings us to a final, really critical trade-off. When you're designing your API, what's more important? Is it perfect, up to the millisecond consistency, even if it's a little slow? Or is it being incredibly fast by using cached data that might be just a few seconds out of date? There is no single right answer here. And learning how to balance these competing needs, well, that's the true art of designing a great API.